All right, so we're on the back page of our ticket to retake for the topic 7 test. We're going to start out with some factoring on this side. So this was the last, gosh, I don't know, half of this chapter was factoring. I feel like we had 4 lessons on it. So when we factor, here's our little guide to factoring. First thing we are always going to do is look for a greatest common factor. We just have to be in the practice of, is there a GCF? Is there a GCF? That's always the first question we ask. So let's look at this first factoring problem and see if there is a GCF. We'll take a look at the coefficients first, 42, 6, and 72. What I do is I look at the smallest number and that's my starting point. I know that our GCF will not be bigger than a 6, but could it be a 6? So is 6 a factor of 42? And 6 is a factor of 42. So my next question is 6 a factor of 72? And 6 is a factor of 72. If you did 72 and you divided it by 6, it would work out with no decimal. So our GCF, we'll write it over here, has a 6 in it. Maybe make that a little bit bigger. Well, there we go. All right, now do these 3 terms have anything else in common besides a factor of 6? And now we start looking at our variables. So I see that the first term has some A's, second term has an A, third term has some A's. So that means we definitely have A's in this GCF. The question is, how many A's do these 3 terms have in common? Well, the first term has an A squared, so that's an A times an A. So we've got a couple A's here. This term only has an A, so they don't have 2 A's in common, but they have an A in common. This one had A times A, which is at least 1 A in common with this. And this one is an A squared, so that's 2. They don't all have A squareds, but they all have an A. So that is the most A's that they have in common. So there's going to be an A in our GCF. Now let's see if we have B's. We have B to the third, B, and B. All right, all 3 terms have B's, so we're going to have a B in our GCF, but what's the most number of B's that they have in common? So this is B to the third. Does this one have a B to the third? Nope, so that's too many. How about a B squared? There's B squared here, but nope, not enough here. How about B to the first? Yeah, this is B to the third, so there's at least a B to the first here. There's a B to the first here, and there's a B to the first there. So we have a B to the first in our GCF. All right, so our GCF is 6AB. Now we're going to factor that out of each term of this polynomial. When we factor out, I think it's really helpful to write it out like this. There's our 6AB. Our GCF 6AB goes out in front of our parentheses. It's a factor of this polynomial. And now we're going to factor each term separately. So 42a squared b cubed, we're going to factor out a 6ab. So factoring is like division. If we have a 42 and we divide it by 6, 42 divided by 6 is 7. Then we had an a squared, but we factored an a out. So if you have an a squared, you factor 1 out, that leaves you with just an a. Here we have a b cubed. We factor out one of those b's. It leaves you with b squared. And then as a quick check, this 6ab times this 7ab squared should equal this. Is 6 times 7 42? It is. Is a times a squared? It is. Is b times b squared b to the third? All right, we got it. All right, moving on to the next term. We have a negative 6ab, so when we factor out a 6ab, negative 6, factor out the 6 is like dividing, so negative 6 divided by 6 is a negative 1. And then we had an a that we factored out, so there are no more a's. We had a b that we factored out, so there are no more b's, so there's just a negative 1 left from that term. All right, then we have a 72a squared b. So 72, factor out the 6, which means divide out the 6. That's going to leave us with a positive 12. We have an a squared, factor out an a, leaves you with an a. And then b, factor out a b, there are no b's left over. And that is factoring out a GCF. After we factor out the GCF, we would consider, oops, could we keep factoring? If we have two terms, maybe we have a difference of squares. So if we take a look at that, we factored out the 6ab. Do we have two terms here? No, this is three terms. All right, so it wouldn't be, oops, I'm gonna make you dizzy here. Wouldn't be this. If you have three terms, you want to look at your a value, and there's some things to factor here. This one, though, this is just a unique polynomial. This 6 or 7a squared b, or 7ab squared minus 1 plus 12a, that does not factor anymore. If we could factor it, though, we would, but that one is done. All we could do is take out a greatest common factor. Okay, next we have this trinomial x squared minus 11xy plus 28y squared. So when we factor, first we're going to look for a GCF. All right, do we have a GCF here? This is an x squared, so there's a 1, which means there's not going to be a common factor other than 1 for the coefficients. And then do all three terms have x's? No. So we would say that there is no GCF here. And when we say that, it's just it's assumed that we understand that that means there's no GCF other than 1. Because we could factor out a 1, but it just won't change that polynomial. So we don't need to factor out the 1. So when we say there's no GCF, we know that that means other than 1. Okay, so this is three terms with an a value. So this is our a value with this x squared with an a value of 1. So let's look at how we factor that. We looked for a GCF. We did not have one. How many terms was it? It was three terms. Did a equal 1 or did a not equal 1? Well, a was equal to 1. So here's how we factor it. We're looking for factors of c that add up to b. All right, factors of c that add up to b. So our c value is this 28. Now factors of 28 are 1 and 28, 2 and 14, and 4 and 7. So we're trying to find a factor pair that adds up to this negative 11. So the 4 and the 7, that's the closest, right? 4 plus 7 is 11. Now we need that to be a negative 11. When you have factors of a positive number, that means your factor pair could be two positive numbers, because that multiplies to positive 28, or they could both be negative. Now, because we need these to add up to a negative 11, we're going to want two negative factors. So the first criteria is they do multiply to 28, but they also add up to negative 11. All right, now you may say, Mrs. Youngberg, you have not talked about those y's yet. So do you see how that's a 28y squared? So if I were to say 28y squared, what that's going to do is this factor pair we found, we're going to put a y with each of those factors. And then factored form looks like x minus 4y times x minus 7y. These are binomial factors because they have two terms, and they are factors because this times this is equal to this. All right. So now we're going to factor this trinomial, 3x squared plus 5x minus 12. So factoring, it's a little closer this time. We're going to look for a GCF first. Is there a GCF other than 1 for 3x squared plus 5x minus 12? And there's not. There's no GCF. So then, how many terms do we have? Are we looking to factor 2 terms or 3 terms? So this is 3 terms. When we factor 3 terms, we have to look at our a value. So the a value, oops, the a value for this trinomial is 3. That is not equal to 1. So that's this one. A does not equal to 1. So anytime that your a value is not 1, we're going to factor with a box. So I'm just going to go ahead and set up the box. And we are going to start by putting terms inside the box. So that 3x squared goes in the top left, that negative 12 goes in the bottom right. All right, so now we're going to use a box, which is an area model, and it says factors of AC. That means A times C. So we have to take A times C. So 3 times negative 12 is negative 36. We want factors of A times C that add up to B. So we're going to look for a factor pair to add up to a positive 9. So factors of 36, we have 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. But these factor pairs are multiplying to a negative 36. Now, to get a negative 36 with multiplication, that means you have to have one negative number. So we need one positive and one negative number in our factor pair. So do we see a factor pair that if we made one of the numbers negative could add up to a positive 5? And as we go through and kind of consider that, if we make this 4 a negative, this is how we're getting that positive 5. So we're going to use the negative 9 and the 4 in our box. We're going to fill in a negative 4. We have to remember this gets an x and a positive 9x. Now I could have swapped these. These could have gone, like I could have put the negative 4x here and the positive 9x there. We would get the same answer. So that part doesn't matter. Now, the way that factoring with a box works is we are just going to pull out a GCF from each row and each column, and that will create our binomial factors. So here we have 3x squared minus 4x. 3x squared is the leading term. When your leading term is positive, we're going to want a positive GCF here. But what's a GCF here? So 3 and 4 don't have any common factors, but both of these have an x, so we're going to factor an x out. All right, now we have 9x minus 12. Leading term is positive, so I want a positive GCF. 9 and 12 have a common factor of 3. And then do both terms have an x? They do not. All right, now we're going to do the same thing but with the columns. We're going to factor and put our GCF up top. First, also it's a leading term is positive, so we're going to have a positive GCF. So factor of 3 and 9 is 3. And then we have x squared and x. We're going to factor an x out. All right, now we're going to find a GCF of negative 4x minus 12. So this negative 4x is the leading term. So I'm going to want a negative GCF. And then 4 and 12, the greatest common factor of those two numbers is a 4. And then both terms do not have an x, so just a negative 4 right there. Now, before we put our answer together, we can double check it right now. We know that multiplying with a box, that 3x times x should be a positive 3x squared, and that is. Is 3x times 3 equal to 9x? It is. Is negative 4 times x equal to this negative 4x? Yep. Is negative 4 times 3 equal to that negative 12? It is. So that just tells me that I'm confident we found the correct GCFs, and also I know that all of my signs are correct. So final answer is going to be the binomial factors. One of them is going to be that 3x minus 4 across the top, and then an x plus 3, because that 3 was positive, across the bottom. So that might have seemed like it took me a long time to explain that problem, but factoring with a box gets easier the more you do it. So um, I guess that's true of most things in life, right? But the better or the more you remember that process, the faster that is. All right, so next problem, we have x squared plus 21x minus 54. We're going to look for a GCF first. Remember, that's always the first thing. There is no GCF here, but we can even write it down so teacher knows we thought about it. It's very impressive to do that. So then we have to ask ourselves, how many terms? Is it 2 terms or 3 terms? And that one was 3 terms. The a value was 1 because it was just an x squared, which means we're looking for factors of c that add up to b. All right, so let's come back to this. Factors of c, which is 54, that add up to b, 21. So your factors of 54 are 1 and 54, 2 and 27. And also, as you're going along, you might get to a point where you're like, oh, these are the factors, and you don't even have to list all of them. We haven't found it yet, but I was just thinking ahead, like, should we list every single factor pair, or can we stop when we find it? And we can stop when we find it. All right, so continuing our list, 3 and 18 is a factor pair. That does not, oh, yeah, it does. That adds up to 21. There it is. All right, so when your a value is 1, you just have that x squared. That's when we can jump right to our binomial factors, x plus 3 and then x plus 18. All right, next problem. We have 4x squared minus 1. So here I can even keep our factoring handy. Oh, well, that's a lot bigger. So first, look for a GCF. Do we have a GCF for 4x squared minus 1? And there's not. They don't have any common factors, so no GCF. All right, the next question that we ask is, how many terms? Well, there are 2 terms. So when you have 2 terms, you want to ask yourself, is this a difference of squares? And if so, then we'll use the difference of squares pattern to factor this. So these 2 terms we have over here, is this a difference of squares pattern? So first, is there a difference? Are we finding the difference? Which means subtraction. So yes, because that is subtraction, that's the first criteria to do a difference of squares factoring. It has to have subtraction. Now the question is, are we squaring anything to get that 4x squared? And we are. We're squaring a 2 to get the 4, and we're squaring an x to get the x squared. So if we square a 2x, that gives us the 4x squared. Are we squaring anything to get that 1? Well, yeah, 1 times 1 is 1. And we're finding the difference. So this is the difference of squares. So when we do this difference of squares, when we put it into factored form, this 2x and this 1, that's what we use in our binomial factors. One factor will have a 2x plus 1, the other one will have a 2x minus 1. It's always 1 plus and 1 minus when we factor difference of squares. All right, 4x squared minus 10x minus 24. So again, I'm going to keep coming back to this, because if we can follow this process, we'll have our factoring down. First, we're going to look for a GCF. All right, let's go back to that. Is there a GCF for 4x squared minus 10x minus 24? So I start with the smallest number because I know our GCF can't be bigger than a 4. Is 4 a factor of 10? It is not. So that means our GCF will be smaller than 4. So the next smallest factor of 4 is 2. Is 2 also a factor of 10? It is. Is 2 also a factor of 24? It is. So that means that our GCF will have a 2 in it. Then I want to look at the variables. I have x's in this term, but not this term. So that means that x is not part of the GCF. So our GCF is just a 2. So we're going to factor a 2 out of all three terms. That 2 is one of our factors, so it goes out front. And then we're just going to factor 2 out of each term, which works like division. 4x squared, factor out or divide out a 2, and then we get 2x squared. Negative 10x, factor out or divide out a 2, we get negative 5x. And then negative 24, we factor out a 2 or divide by 2, we get negative 12. Okay, so now we have a factor of 2, and now we have this. We're going to see if we can keep factoring this. So let's go back to, here's our process. We took out a GCF, and then how many terms do we have? So that was 3 terms. So we're over here in 3 terms. Either A equals 1 or A does not equal 1. So let's go back and look at 3 terms. Oh, here's our new A value. It's a 2. So A does not equal 1, which means we are going to factor with a box. So let me go ahead and draw the box. We fill in the box with the 2x squared in the upper right and the negative 12 in the, I'm sorry, that was upper left, and the negative 12 in the bottom right. All right, now to fill in the other 2 boxes, we're going to do A times C. So 2 times negative 12 is negative 24. And we want factors of negative 24 that add up to negative 5. So we've got 1 and 24, 2 and 12, 3 and 8, and the 3 and 8 is going to work. But because that's a negative 24, we need one of these numbers to be negative. If we make the 8 negative, now it adds up to this B value of negative 5. All right, so we're going to fill in our box with a 3x and a negative 8x. And now we're just going to factor out a GCF from each row in each column. So 2x squared plus 3x, the only thing that this row has in common is an x. Leading term was positive, so positive GCF. All right, now negative 8x minus 12. Leading term is negative, so our GCF will be negative. And then what's the greatest factor for both an 8 and a 12? And that's going to be a 4. All right, now we've got 2x squared minus 8x. Leading term is positive, so we'll do a positive GCF. And the GCF out of those two is going to be a positive 2 and an x. All right, last we have 3x minus 12. Leading term is positive, so positive GCF. And what's a common factor for 3 and 12, or 3x and 12 is just going to be a 3. Now let's do a quick check. Is 2x times x 2x squared? Yes. Is 2x times negative 4 negative 8x? Yes. Is 3 times x 3x? Yes. Is 3 times negative 4 negative 12? Yes. Okay, the reason why it's worth it to double check that is you might have pulled out the wrong GCF by accident. Maybe you have a negative somewhere it shouldn't. And so that just helps us feel confident that we have factored that perfectly. All right, so across the top, we've got this 2x plus 3. There's one of our binomial factors. On the left, we have this x minus 4. That's the second binomial factor. And then it's going to be easy to forget, but that 2 is one of the factors, so that goes into our answer of factored form. All right, last question. Find the area of the shaded region. All right, so the shaded region is a random shape. I don't have an area formula for this shaded region, but I can see that I have a big rectangle and a small rectangle. If I could take away this small rectangle, it would leave me with the shaded region. So what we're going to do here is we're going to find the area of the big rectangle, the whole thing, all of it, and then we're going to take away the area of the small rectangle. If we remove that, it will leave us with the shaded region, which is what they're asking for. So first, let's find the area of the big rectangle. Area is length times width, so we're going to have a 4x minus 2 times an x squared minus 3. All right, let's see, maybe I'll set that up with a box. Why not, right? So when we're multiplying with a box, the 4x minus 2 goes out and the x squared minus 3 goes on the left, and then we just fill in our box. 4x times x squared is a 4x to the third. Negative 2 times x squared is a negative 2x squared. 4x times negative 3 is negative 12x, and negative 2 times negative 3 is positive 6. All right, as I look at that, there are no like terms, so it's just going to be 4x cubed minus 2x squared minus 12x plus 6. That's the area of the big rectangle. Now we need the area of the small rectangle also. All right, the small rectangle, the length times the width is x times x plus 2. All right, that's just a simple distributing. X times x is x squared, x times 2 is 2x. Okay, so we said if we take the area of the big rectangle and we remove the small rectangle, it will leave us with a shaded region. So here we have our big area of the big rectangle. Now removing is subtracting, so we're going to subtract the area of the small rectangle. When we subtract, remember we on the first page talked about the best advice I could give you for subtracting is to make this a negative 1 and distribute. Negative 1 times x is negative 1x squared. Negative 1 times 2x is negative 2x. And then we cross it off because we took care of that subtraction. I'm going to carry down the problem for x cubed minus 2x squared minus 12x plus 6. And now we can just combine like terms. To put it in standard form, I'm going to go for highest exponent first, so 4x cubed. Then I'm looking for x squared. We have a negative 2x squared plus a negative 1x squared is a negative 3. Remember, variables and your exponents don't change when we're just adding terms together. Negative 12x minus 2x is a negative 14x. And then we've got that plus 6. So that is the area of the shaded region. We subtracted out that middle rectangle that we removed. And then let's just go ahead and throw a units squared on this because this is an area measurement.